Hello friends, welcome to engineering tutorial. In today's video we are going to discuss about another logic gate, which is the exclusive OR gate or XOR gate. Okay, it is also written in this way and also in this way, so never get confused if you uh, see either of the two ways in which the exclusive OR gate is represented. Okay, so similar to the three basic gates, the NOT, the OR, the and the two universal gates, it takes certain logic levels. It can have multiple inputs, but here we are considering only two inputs and it gives a certain output. So let us say we have the XOR gate block. It has two inputs, let's say. It can have multiple inputs, but here we are considering only two for simplicity. It has two inputs, A and B, and the output, let's say it is Y. So the output of the XOR gate, it is written as A complement and B plus or A and B complement. Okay, A complement and B or A and B complement. You can also remember it in your own way, that is A bar dot B plus A dot B bar. You can also remember it that way if it makes you easy, the remembering process easy, but actually this is complement of A, and this dot represents and this plus it represents OR. Okay, so it is A dot B, A complement dot B plus A dot B complement, where the symbols represent the usual respective operations. This is the output of the XOR gate. Okay, it is also written in this way: A or B and A complement or B complement. Okay, it is also written in this way. Either of both of them are correct. If we solve it, we'll get A dot A bar plus or AB bar plus or A bar dot B or B dot B bar. We are so used to using the word plus, so if I say plus, it means it is OR. Okay, don't think that it is arithmetic plus. By mistake, if I say plus, it means it is OR operation, and this dot, it represents AND operation. Okay, we know as per the rules of Boolean algebra, A dot A bar is 0, this stays as it is, A dot B bar or A complement dot B, and again as per the rules of Boolean algebra, the product of the signal with its complement is 0. So we get this value, A complement or and B or A and B complement. Okay, so these are the two ways in which the output of the XOR gate can be written. Now let us see the schematic symbol of the XOR gate. So the XOR gate is similar to the OR gate. Okay, only there is a minor difference. In OR gate we have this symbol, okay, this shark fin shaped structure. In order to convert it into an XOR gate, we add another, this curve like before. Okay, so there are two curves, inverted C you can also say, along with this shark fin shape structure. So here the two inputs A and B, and this is the output Y. So this is the schematic symbol of XOR gate. The output of the XOR gate is also written in this way: A XOR B. So this plus sign, which is enclosed by a circle, it represents XOR operation. So whenever you see this symbol, it means XOR operation, which is equal to A bar B plus AB bar. So plus, when I say plus, it means OR, and this dot, it represents AND. So if I miss this dot also, you understand that this is AND operation. Okay, in a hurry I can miss this dot, it means it is AND. Okay, in digital circuits, product means AND, addition means OR. This thing you should be clear. Okay, so this plus enclosed by a circle, it is XOR operation, and this is the schematic symbol of the XOR gate. Now let us discuss the input output relationship of the XOR gate with the help of the truth table. Okay, so the input output relationship, we have two inputs A and B and one output Y. This is A bar B plus A B bar. So as there are two inputs, there are four possible input combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay. So when both the inputs are 0, it will be 0 complement dot 0 with 0 to 0 complement, which will be 1 into 0 plus 0 into 1, which will be equal to 0. So this is 0 for this. Okay. So when both the inputs are 0, the output is 0. When A is low and B is high, that is A is 0 and B is 1. So it is 0 complement and B, which is B is 1, OR operation. Again this is 0 and B complement is 1 complement. So it is 1 and with 1 plus 0 and with 0. In this case it is 1. Okay. So similar to this A0 B1, when A is 1 B is 0, we will get output as 1. Okay, similar to that, only in this case B is 0 and A is 1. And when both A and B are 1, it will be 1 complement 1 plus 1 1 complement, which is 0 1 0, which is equal to 0. So in this case the output will be 0. So here you can see that there is a unique feature of the XOR gate. Okay, see here the two inputs are same, both are high, A is 1 B is 1, and the output is 0. And in this case also both the inputs are same, both are equal, A is 0 B is 0, both are low and the output is 0. And only in these two cases, when the inputs are different, that is one is high, other one is low, or one is low and the other one is high, the outputs are high. So this is the unique feature of the XOR gate. When both the inputs are of the same nature, when both the inputs are equal, be it high or be it low, when both of them are of equal value. When both of them are equal, the output will be low, and when either of the two inputs are different, one is low, other one is high, or one is high, other one is low, the output will be high. Okay. So this is the unique feature of the XOR gate. When both the inputs are of the same nature, when both the inputs are equal, 0 0 1 1, the output will be 0 or low, and when both the inputs are different, that is either 0 or 1 or 1 or 0, the output will be high, logic 1. So this is the input output relationship of the XOR gate. This is the unique characteristic of the XOR gate which you should remember. Same nature of inputs, low output, different nature of inputs, different inputs, high output. Okay. So here we have discussed about the basic concepts related to XOR gate, that is the output expression, the schematic symbol, and the truth table. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.